In the last lecture, Eric showed you that futures are monads, and that means they have a flatMap operation. And he also showed you that it's quite advantageous to write your code in terms of flatMap rather than the pedestrian onComplete that you've seen before. But overall, it was a bit mystical what this flatMap is and how it hangs together in onComplete. So I thought I wanted to fill that in. And what I want to do is take a closer look at flatMap and how it could be implemented in terms of onComplete. Now, in actual fact, the actual implementation of flatMap in the futures library is a little bit involved. It uses execution contexts, which we have omitted so far, and it has to do some thread scheduling. So what we are looking at here is something simpler, a simplified but complete implementation of flatMap. And what's nice about it is that implementation is in fact almost automatic. All we need to do is follow the types. So let's get started. So we have our trade future, and we call this in the future self for future reference. In the future, there's the operation flatMap with the type that we have seen here. What can we do with it? We have to produce a future. Well, let's just start by creating a new future. And when we create a new future, what do we have to do next? Well, we have to give it an onComplete method. So here's the type of the onComplete method. So how would we implement onComplete? Well, what can we do when we're in the future? The only thing we can do really is to call onComplete on ourselves. So let's do that. The onComplete method here now has an implementation that we say self, that means the current future, onComplete, and here are the two cases. So we now need to fill in the success case and the failure case. What do we do in case of success? Well, if in case of success we get a value x, so what can we do with x? The only thing we can actually do here with an x of type t is call f on it. That's really the only thing that's available to us. So that will give us a future of s. Good. What do we need as a result type of onComplete? A unit. So how do we go from a future of s to unit? Well, we have to use callback. So let's try that and write f of x dot onComplete callback. So we compute the future f of x, call onComplete of it, and pass the result along to callback. There's really no other thing we could have done given the types we have in hand. Now in the second case, when we have a failure with exception E, what can we do? Well, the only thing we really can do is pass that failure on to the callback. And that completes the implementation of flatMap on future. You see how it can be written in terms of onComplete. And furthermore, you've seen that essentially once we've settled on the types and a general strategy, we didn't really have any choice in each particular step. We just had to follow the types, and the code wrote itself. In fact, the actual implementation is somewhat more involved, since it also has to handle thread scheduling, but I believe the implementation you see here can serve as a good reference model to really understand what flatMap on a future does and how it can be implemented in terms of onComplete.